Imagine this. You walk into a stadium that holds 10 million people. It's been set up for a massive gathering. Lights on, microphones ready. But it's silent. You're the only one there. That feeling, that eerie silence, that's what it's like when scientists look into space. We expect life to be everywhere, but what we find is nothing. This mystery is known as the Fermi Paradox, and it's one of the most captivating questions in science, and maybe the most important one. Let's decrypt it. Here's the basic idea. There are over 200 billion stars in our galaxy, the Milky Way, and at least one planet for every star. That's 200 billion planets. Thousands of them are in what we call the habitable zone, the region around a star where liquid water could exist. Many of these planets are older than Earth. So logically, intelligent life should have appeared long before us. If even 1% of those planets developed civilizations, we'd expect thousands of advanced societies out there. And yet, we hear silence. No radio signals. No spacecraft. No alien cities. Nothing. So where's everyone? This is what Enrico Fermi asked in 1950, over lunch, joking about aliens. He realized something powerful. If life is common and space travel is possible, we should have been contacted by now. The fact that we haven't is a paradox. What makes the Fermi Paradox so compelling isn't just math. It's what it forces us to consider. It makes us question, are we really alone? Is intelligent life incredibly rare? Or does something happen to civilizations before they can spread? It doesn't matter if you're a scientist, a philosopher, or just someone who looks up at the stars. This paradox shakes something deep inside us. It raises the biggest questions we can ask. And some of the answers are unsettling. Let's explore the most popular theories behind the Fermi Paradox. The first is called the Great Filter. This idea says that there's a filter, a barrier, somewhere in the timeline of life. It could be the leap from single cells to multicellular organisms, or the jump from intelligent life to spacefaring civilizations. Or maybe civilizations destroy themselves before they ever leave their own planet. Nuclear war, climate collapse, rogue AI, whatever it is, it stops them. And here's the twist. We don't know if the filter is behind us or still ahead. If it's behind us, we're rare, maybe even unique. But if it's ahead of us, we may be doomed, like countless civilizations before us. Another theory is the zoo hypothesis. What if aliens know about us, but they're deliberately keeping their distance? Like humans watching animals in a preserve. They may be observing, silently, waiting for us to reach some kind of threshold. Maybe a level of peace or technological maturity. Or maybe they just don't think we're worth talking to. Yet, then there's a "they're already here" theory. This one suggests aliens are around us right now, but we can't recognize them. They might be post-biological, digital life forms, or exist in dimensions we can't perceive. They could be using stealth technologies beyond our understanding. To them, we might look like ants, unaware of the highway running above us. Another explanation? We're too early. Maybe the universe is still waking up. Stars will continue forming for trillions of years. We could be among the first civilizations to evolve. In that case, the silence isn't a warning, it's an invitation. We're the pioneers. There are even more extreme ideas, like the dark forest theory, where every civilization stays quiet, fearing others. Because in a universe where you don't know who's friendly, broadcasting your location could be a death sentence. Or the simulation hypothesis, the idea that this universe isn't real. Maybe aliens don't exist because the simulation doesn't require them. It sounds strange, but even some scientists take it seriously. So what does this all mean? Why does the Fermi Paradox matter? Because it's not just about aliens. It's about us. It asks if we'll survive long enough to explore the stars. It asks if civilizations are destined to collapse. And it asks, if we are truly alone, what responsibility comes with that? If Earth is the only cradle of intelligent life, then our actions, right now, shape the future of the galaxy. The Fermi Paradox is fascinating because it forces us to confront the unknown. It blends science, philosophy, and imagination. It reminds us how little we know and how far we have to go. And maybe that's the point. To keep asking questions, to keep searching, to be the voice in the silence that says, we're here, we're listening, and we're ready to understand the universe and our place in it. This is why Decrypted. Subscribe for more mysteries unraveled, one why at a time.